Hello, my good friends out there. Good day to all of you. I am Dr. Diaju, your chemistry lecturer on social media. My past lecture, or the previous lecture we had, was some calculations based on Dalton's law of partial pressures. I think we have done with Dalton's law of partial pressures. So right away, we have been dealing with the topic Lusac's law of combining volumes. Lusac's law of combining volume. Lussac is another scientist who provided this law called Lusac's law of combining volumes. Let me read to you the prevailing definition of this law as in some textbooks. Thereafter, I will also define this law in my time when I was in secondary school in the 70s. We compared the two, which one is preferable to you take. Now listen carefully. The law states that the volumes of gases which take part in a chemical reaction bear a simple whole number ratio to one another and to the volume of the products, if gaseous, when measured at constant temperature and pressure. That is the definition from other authorities. Now, in my own time when I was in secondary school in the 70s, Lusac's law is defined as follows. When gases react, they do so in volumes, which bear a simple ratio to one another, and to the product, if gaseous, provided the temperature and pressure remains constant. That is how we define it in my time in secondary school in the 70s. Now, having said that, let's go. Now look at this first reaction. Hydrogen combining with chlorine to give hydrogen chloride gas. Now, according to Lusac's law, based on this first equation, see what he said. He discovered that one volume of hydrogen reacted with one volume of chlorine to produce two volumes of hydrogen chloride. The equation for the reaction also shows a molecular ratio of hydrogen to chlorine to hydrogen chloride. That is 1 to 1 to 2. So what is saying here? Now, if you look at this equation here, it is saying that one volume of hydrogen gas reacted with one volume of chlorine gas to form or produce two volumes of hydrogen chloride gas. That's what it's saying. And with this equation here, we can determine the ratio of the proportion of these various gases in reaction. That means 1 is to 1 is to 2. That's what it's saying. The ratio is now 1 is to 1 and is to 2. That's what it's saying. So, it's now saying also that when the gases are reacting, they're not reacting with the whole of their volumes. There are portions of each of these gases that are taking part in the reaction. That's what it's telling us. Now, according to the Lusac's law, it still also says that the total volume of the reacting gases do not be equal to the gases produced. It's not that it's not compulsory that the volume of the gases reacting must be equal to the volume of the product formed. That's what it's telling us. Now see the second question here. Here, if we are going by the Lusac's law, it means two volumes of hydrogen gas reacted with one volume of oxygen gas to produce two volumes of water vapor, which is steam. Now, if you're going by the ratio, it means here is 2, here is 2 to 1 to 2. So, what is saying that these two reacted to produce this. It is not compulsory that the volume of the product produced must be equal to the volumes of the reacting gases. That's what it's telling us in this second part of it. So now, in the above reaction, that is this one now, two volumes of hydrogen combine with 1 volume of oxygen to produce 2 volume of steam, that I've just said. Hence, the volume ratio will be 2:1:2, this I've just said here. Now, he is saying that this law is applicable only to gases. But whether it's ideal gases or real gases, we do not know, but it's applicable to only gases. But now, the big question is this: how did the Lussac law, determine the volumes of the reacting gases? I'm asking that question now. I'm also asking you, how did he determine the volumes of the reacting gases? Here he said 1 volume, react with 1 volume to give 2 volumes. Here he said 2 volumes, react with 1 volume and to produce 2 volumes. So how did he determine these volumes? Now, the simple answer is that he got this by balancing the equation. Once the equation is balanced, then the coefficients will represent the volumes of the combining elements. So, now, and when you are balancing a chemical equation, you must obey and respect the law of indestructibility of matter, which holds that matter can neither be created nor destroyed, but can be converted from one form to another. So, if you don't do so, it means that you have either destroyed or you have created. So, as a chemistry student, it is very, very significant that once you put down a chemical equation of this nature, you must be able to balance the equation. And when you balance the equation, the coefficients will tell you the volumes of the respective volumes of the gases that are combining in that reaction. So, like it, please comment and follow me. Always subscribe to my YouTube channel